words, what would you say a proportional relationship is? Look up at 1 and 2. You saw that 1 was not proportional and 2 was proportional. What could you describe that as if someone asked you, what's proportional and what's a proportional relationship? Jot down something right here in this box. You could draw an example, like number 2. You could say some words, 1 or 2 sentences. Guess you could draw a picture. Max?
Are we going to do number 2?
No, cross that one out. And if you don't have a partner, look behind you, left or right. 10 seconds, finish up your thoughts. You're going to share out. If you are an odd, raise your hand. Corbin, you're an odd. Mara, you're an odd. Logan, you're an odd. Odds, what's a proportional relationship? 20 seconds, go. The same ratio. 3, 2, 1. Proportional relationship is what? Silent hands. Logan.
A proportional relationship is a number that you multiply by, and it's the same number for all of the numbers.
I'm going to back up, and I'm going to put this answer right here. The constant is the number that you multiply by. To get proportional relationships, to get a proportion. So that's a great start. A constant is the number you multiply. So a constant would be written as k. Okay, we got that. What would a proportional relationship be, though? It does simplify to k. We can maybe use this in that, Liliana. 2 fractions or ratios that equal the same thing when simplified. Good. That's a great start. Anyone have something to add? Proportional relationships have the thing Logan was talking about, constant of proportionality. Which is the constant ratio between 2 quantities. It is written as k. Those 3 things should be in your pockets. If you did not quite know what they were, you'll need them for today's lesson. Next page. Anyone still writing? Okay, I'll give you 10 seconds. Write the aim if you are done with that. Cool. Look at that. There's some grids on your page, which are why we did that in the warm-up. Today you're going to be graphing proportional relationships, which is why we started with a graph. You have learned 2 ways to tell if things are proportional. 2 types of problems, and I'll give you a hint. The 2 types were on your warm-up. Before we did the grid, they were on the first page. The first way that we learned was to compare 2 ratios. What were the 2 ratios we compared in example 1? Or in number 1 for the warm-up? Cameron?
3, 7, 12.
We compared 3/7 and 12/21, which we said wasn't proportional. I could change this thing to 6/14, And we could compare those two, and those would be proportional. If you simplified 6/14, you'd get 3/7. A second way we've learned is to find the constant. I'll just abbreviate it as K. Find the constant in a table. You can go through every pair in a table, x and y, and divide y over x to find if it's proportional. We've done 3 days of that. Today, we're going to learn a third method, and it might be the easiest method out of them all. That's why I saved it for last, because hard work is always best in the beginning, in my opinion. We can graph ratios, which should be a ratio. Spell check. We can graph ratios on a coordinate grid. Wow, there's a lot of writing today. Think your hand after you finish that. We're going to graph them in a coordinate grid. And we'll see if it's proportional. Okay, so look at your table. You have 3 sets of points. Your table is always written as x first, then y second. So we're going to start with x, then y. The x value is 3. Let's run over to 3. We're here. Now we're going to jump. Here's our coordinate pair that we're graphing. 3, 2. So let's run to 3, jump up to 2. Make a point. Then run over to 6. Jump up to 4. 1, 2, 3, 4. Make a point. Then run over to 9. Jump to 6. 1, 2, 3, 4, 5, 6. Yeah.
We used to do this for like covering notes.
Yeah. Most of us have this kind of familiar. Did you have an actual lesson on it, or was it just like a bonus?
We did lessons on it, and then like
oh, cool.
Some days she like just give us a packet.
Awesome, great. So
she
that
gave
is
us like a packet.
Awesome news. Cool. You guys were in like the kind of advanced 5th grade. That's probably why. I don't know if it's a 5th grade standard, but maybe it is.
I don't think so.
I don't think it was because it was like something that you didn't. It was something else.
Yeah, because Ms. Gordon's class did their math class like they were still on fractions.
Cool.
Ms. Kester's class was doing something different.
That's great. So let's head to this guy and let's compare things. If I look at this graph and I want to see what the constant is, the constant is always y over x. I want you to draw little stairs going up. So I went from 0 to 2, and then 2 goes over to my next dot. Draw a stair. You just went up 2. That's your y value. You just went over 3. That's your x value. What does that look a lot like? It kind of looks like the constant of proportionality. When you graph something, you can draw stairs up 2 over 3 to get your constant. Go up 2 and over 3. Every time it is proportional, it will have a constant that you can see on a graph. In other words, what does the line look like when you graphed it? It looks like a straight line. It goes in a straight direction up a certain way. It also starts at 0, 0. This thing we can look at and immediately say, yes, it's proportional. Because it goes through 0, 0, and it has a straight line that goes up 2 and over 3, you can say, yes, it's proportional. You can literally look at any graph they give you, and you can say yes or no just by using your eyes. If you have something that gives you a graph on a test, I do not need to see work. If it's asking just for the yes or no, you can look at it and say yes, look at it and say no. Let's do 2 more. Use the graph to tell whether x and y are proportional. If yes, we're going to create an equation, which I don't want you to do yet. We'll do the equation later. Let's plot it. This time you have an x and a y, and your ordered pair first is 2, 6. Since it's a horizontal table, you're going to look at x and y across from each other and graph that. Then graph 4, 8. Then graph 6, 10. Cameron, you think it's what? Okay, let's check. Over 2, up 6. Over 4, up 8. Over 6, up 10. And draw your line. Interesting. What do you notice a few things about this table or about this graph? Daniel. And the ordered pair goes up 2 over 2? Yeah, okay. Up 2 over 2, up 2 over 2. It's a straight line. Tessa, what else do you notice? It does not go through the origin. When you look at this graph and you see that it's not through 0, 0, you can automatically say, no, not proportional. For something to be proportional, it has to have two things every time. It has to have a constant rate of change. It has to go up like a staircase, and it has to start at 0. If it doesn't start here, it's not proportional. If it doesn't start at 0, it can't be proportional. Yeah.
I found the number that I did.
Oh, nice.
So I did.
And last one. 1, 2, 2, 4, and 3, 6. Help me plot this first point, Sierra. Where do I plot 1, 2? Good. Run, then jump. Help me with 2, 4, please, Chad. How do I graph 2, 4? Okay. And Kate, how do I graph 3, 6? Okay. Connect the dots. Just using your visual mental math, is this proportional? Thumb up or thumb down? Hands down. Reese, what's one thing you see that makes it proportional?
It starts at the 0, 0 right there.
Great, and that's called the origin. It starts at the origin. Say origin on 2. 1, 2. Origin is 0, 0. It starts at the origin. That's your first test it needs to pass. Second is it has to have a constant rate of change. Let's test the rate of change. Go up 2 over 1. This stair shows you it's proportional because it goes up 2 over 1. Every single dot you draw in will have 2 up over 1. Yes, it is proportional. Can somebody tell me what the constant would be? Logan.
It would be K equals 2 over 1.
Great. 2 over 1, 2 over 1, 2 over 1. It is proportional. Big idea for two ratios to be in a proportional relationship on a grid. The line must do two things. The line has to have a constant rate of change, meaning it has to have a k value that's the same. It's got to have a constant of proportionality. It also has to go through what? Whole class? The origin. If those two things are on the graph and you can see it, you can just put yes. You try these two on your own. 8, 12, you're not going to be able to graph because it'll go off, or 12, 8. You can either add a 11 and a 12, or you can just cross it out. That's fine, yeah. Over 3, up 2. And I'm going to pass out a ruler for your next example. You guys have never used these? Back me real quick. This is a geo template. It's not something that you draw on. It's not something that you go like this with. It's not something that you use to spin on your desk with your pencil and make like a cool little
Pattern.
spinning This is a ruler that we use, and we'll use the shapes for later. So only use this as a straight edge. If I see anybody else using it or you treating it disrespectfully, like breaking it, I'll take it immediately and give you a old ruler. There will be a time when I can give you a chance to make cool shapes, which will happen probably in about 5 minutes if we get through this. Do not use it right now as shapes, use it as a straight edge. After you connect the dots, you should use this straight edge to draw your line. Draw a straight line. Where does 6 4 go? Over 6?
Well, no, that was his person. That's what I did. What?
We go through it soon. You did 2
They're off.
Yeah. What? We will. Yeah. Let's check. Okay, 3, 2, 1. So when you graph 3, 2, thumb up if this is proportional. 6, 4, 9, 6. Thumb down if it's not. For number A. A should be proportional. It goes through the origin, and it has a constant rate of change. Is B proportional? Thumb up or thumb down. B is not proportional, Max. Tell me one reason why.
Because it doesn't go into the order.
It does have a constant rate of change. However, it does not go through 0, 0. This would be no. A would be yes. Bonus, who can tell me the constant of proportionality for A? Liliana. Close. It's always going to be y over x. So what would it be? We could flip it, Liliana, and make it, instead of 2 over 3, it'd be 3 over 2. Wait, sorry, instead of 3 over 2, it'd be 2 over 3. 2 over 3. 2 over 3. Cool. Next page, last example.